In this video, I'm going to go over Little's Law and to produce the NP metric in iperf 2.0.14. You can get more information on Little's Law online, like at Wikipedia. But what we're going to calculate is the effective queue depth, which is called L, is equal to lambda, which is the arrival rate, times the average service time. For this to work, you're going to need the trip times option as well as clock synchronization. And for within the calculations, what's being used with iperf is lambda is the TCP send rate, and W is the average burst service time or speed to service that burst across the pipe. So let's get to the example, and here's the page on Wikipedia. Like we said, to start, you're going to need to make sure your clocks are synchronized. So there's different ways to do that, and let's just double check, make sure these clocks are synchronized, and they look to be, whoops, sorry, try that again. They're synchronized to a GPS clock, so these clocks should be pretty well synchronized. So let's start the iPerf server. You don't need that there. And then to enable the trip times option, the this is the dash trip times will enable the ability to produce the NP metric. For this run, I'm going to go ahead and use Google's BBR and adjust the window a little bit. And so what you'll see happen is the trip times option will be indicated on connect. You'll see the burst, the latencies, which is these latencies. And what you're looking for is this metric right here, which is the how many, the L value, how many bytes are in queue, effectively in queue. And this is from an end-to-end perspective. And to give you an example with changing that, if I don't check this window, what you'll notice is that that in this case you can see a lot deeper queue depth because the latency are a lot higher. Latencies are now, instead of 364 microseconds, they're like almost 3 milliseconds, and so your effective queue depth went up. And then again, this is the NP metric, and you'll notice that here in Little's Law, and the units are bytes, and it's the same for both UDP with the units being in bytes.